What up, peeps? Here we are. Today, metabolism. Now, you should stop the video right now. What are the 4 macromolecules of the human body? Stop, come back when you're ready. Okay? You should know that. 4 macromolecules: proteins, carbs, lipids, and what's the 4th? Nucleic acids. Basically DNA, RNA. Turns out by mass, they don't make up much of our diet, all right? And they're also very easy to break down. Phosphates, sugars, very easy. So we don't really need to even talk about them. They're so easy. Lipids, carbs, proteins have a more involved metabolism, and that's what we're going to do. Now, at Pima in our classroom, I normally, you know how we have 3 whiteboards? I normally put one of these on each of the 3 whiteboards. So I put proteins on the left board, carbs in the middle, lipids on the right. So today I have to condense like 18 feet of board space into whatever this is, like 3 feet of board space. So our reduction factor of 6 to 1. Somehow we're going to make this work. So proteins, remember, what are proteins? What are proteins? Protein is a big string of beads where every bead is a what? Is an amino acid. Remember, what are amino acids? Amino acids are aminos that have acids, and you know that. So here, NH2, that's the amino, the amine group. Carboxylic acid, amino acid. Hydrogen here, residue, this is where, you know, like 18 or 20 to 22 amino acids in your body for metabolism and stuff. This is where they all differ from one another. Mostly down here is going to be carbons, hydrogens, and oxygens again. All right, there are going to be some nitrogens, some sulfurs, other weird things from time to time, but mostly C's, H's, and O's. So when your body metabolizes amino acids, remember first the proteins got broken down. So proteins are amino acids. Remember, this started getting broken down in your stomach, you know, pepsin, and then in the small intestine, the proteases, all right, trypsin, chymotrypsin, carboxypeptidase. They're breaking down proteins into amino acids. They're finally hitting the brush border, breaking down into individual amino acids. So next we have to deaminate. That's how your body does it. Your body processes the C's and the H's and O's in one pathway, has its own special pathway for the nitrogens. So we deaminate. We have to cut off the amine group. Remember, how many things does nitrogen like to grab? Yes, it's anthropomorphic. I don't care. Get over it. Carbon likes to grab 4, oxygen likes to grab 2. How many does nitrogen like to grab? 3. And what's the easiest thing to grab? What's the closest thing nearby? Hydrogen. So what do we end up making then? So when we deaminate, all right, we're going to take an NH2, all right, and that's going to pick up another hydrogen, all right, and so when we deaminate, we get the hydrogen. We now have NH3. We have produced now NH3. And what is NH3? That's ammonia. We ain't got no damn windows inside of our body. We don't. Ammonia's for cleaning windows. We don't need to clean no damn windows, all right? No windows in your blood vessels. No windows in your liver. So what happens is the liver takes the ammonia and it converts it using the urea cycle. We saw this before. Or the ornithine cycle into urea. Urea, what we're going to use to get rid, that's what urine. Urine. Same word. Urea, urine. Urea goes into the urine. We excrete most of our urea that way. Okay? So that's how we get rid of extra nitrogen. We can use the nitrogen, your body does. It takes amino acids and it uses them to make proteins. But this is the stuff that we can't use. We get rid of it, all right? Remember then that when you look at blood work, you're going to see a BUN, blood urea nitrogen. That's going to be a measure of the overall nitrogenous waste in the blood. So what's that going to be? Well, it's going to be ammonia, because we just did that. I mean, we just saw there's ammonia in the blood. All right, so there's ammonia, and God, and then there's the ammonia that we converted to urea, and then from the breakdown of nucleic acids we get uric acid, And from the breakdown of creatine, we get creatinine. Remember? These are, I have this on that sheet, creatinine. On that sheet of essential knowledge for Bio 202 I gave you the first day of class, these are the things on there. It said make sure to know these. These are the waste products likely to be found in the blood, plus lactic acid, which we'll talk more about later. So there's your BUN, ammonia, urea, uric acid, creatinine. So that's what we did with the amine group when we deaminated. What happens over here? Oh, the sun just went behind a cloud. It just got darker, didn't it? I'm relying on outdoor light in order to light this. I don't have, it's not like the public access studio where I've got, you know, the big giant banks of lights and stuff. So remember what's left mostly after we take off the NH2? C's and H's and O's. So C's and H's and O's are then sent down here and made into keto acids. So watch out here. Don't mix up keto acids with ketone bodies. We're going to talk about ketone bodies later. But they both have ketone groups. Keto acid has a ketone, remember a carbonyl group, a carbon double bonded to an oxygen with two side chains hanging off. So we got a ketone group, and it's also got a carboxylic acid, so we call it a ketone acid. These are really handy acids because they can be converted to this molecule here called acetyl coenzyme A, which is the magic molecule of metabolism, M cubed, the M to the M, the magic molecule of metabolism. So keto acids are useful. Like oxaloacetic acid, we all see that in photosynthesis, in CAM photosynthesis. No, we didn't cover that, did we? That's a different class. Okay, and then what I'm going to do here, these keto acids can be converted into acetyl coenzyme A. And I'm going to put two arrows going from keto acid to acetyl-CoA because that's going to be involved in two different pathways that we're going to see coming up. So this is where we're going to end. We're going to do 3 videos here in order to keep the files small so they don't take like 4 hours to upload. So did proteins, then we're going to do carbs, we're going to do lipids. So this is basically the end of our first little video here on metabolism. So keep in mind, in summary, then this is how your body metabolizes proteins. Proteins are made of amino acids. We use enzymes to break it down into that. We deaminate, then go to the liver, the urea cycle, turn into urea. The CH's and O's, convert those to keto acids. Those can be converted to acetyl coenzyme A, and then the magic happens. All right, so I'll be back and we'll do carbs next. Oh, shit.